And here we're live. Hello, Internet, and welcome back to episode number 2 of Rubber Duck Engineering. I'm Eric Seidel.
And I'm Adam Barth.
And I have to say, this is the highlight, or one of the highlights of my week. I've been looking forward to this ever since we hung out last Sunday. So I'm excited. Do you have things you want to say to the Internet before we dive into the code, Adam?
No, I just think we should remind ourselves like where we were and what we were working on.
Yeah, so we started playing around with how we could go about visualizing sound. And so we started a project, and we figured out how to use GitHub. We got ourselves a project started. Thank you, you did that. And then we used Flutter, which is this technology so you can write once and deploy it to lots of places to build a very basic sample project. We ended up not doing the visual parts yet. We're solely working on the command line. Because we decided we need to be able to read a sound file, and we couldn't find the sound library we wanted on the internet, so we're just building one. So we're in the middle of parsing a wave file. We got into, we started parsing the header of a wave file, and I think we'd parsed the first 4 fields, and we'd written a test, and then we ran out of time.
This reminds me of like you have a sort of like grand vision of where you want to go with this project, right? It's like you want to visualize this sound, and then you start getting into it. And you're like recursively going, like, okay, and the first 4 bytes of the file are RI.
Correct. So I'm hopeful that maybe we'll have parsed the entire wave file by the end of our hour today. But
sounds like a great goal.
Well, we'll see. So as promised, I didn't do anything offline. Adam and I did figure out how to use some sort of Visual Studio live sharing thing so he can type on my screen. Crazy. We're using it for the first 5 minutes here, so bear with us.
My security hat on. I kind of wonder what this is possible, what this is capable of, but we'll find out.
We'll see. And I also, as promised, fixed my Flutter installation, which was like a random version, hacked up version of Flutter Master from January of this year, because I also work on the project, to be last week's beta release. So with that, all of the red squiggly lines that were everywhere of the Dart analyzer being crazy are now gone. So with all that said, let me figure out how to switch to, I got to share my screen. By the power of the internet, I'm sharing. Ta-da! And there we go.
Can I try out the live editing thing?
Oh, please. There we go.
Oh my gosh, it worked.
No hands.
That's amazing. All right, I'll remove that from your beautiful file.
So this is like literally the exact file and everything setup we had when we left. This is our test that we ran. Now that we have a working setup inside our ID, we can just click run here. And it'll show our debug console. Oh, don't make me a fool. There we go. Okay. So this showed up when I upgraded Flutter, and we should go fix this. This bug is telling us that when we specified our version of test that we added, and we went to the trouble of following the instructions on the pub website. Pardon me, when I'm looking away, it's because I'm looking at the code, not at you, our internet fun friends here. This is what this message is telling us is that Flutter itself depends on a specific version of test. And so we just have to let Flutter be in charge here instead of specifying our own one. And so we're just going to change it to any. It'll refetch, and this will go away. For most packages you depend on, you would specify a version constraint, not any. Pub gets running. We can go back to our test while this runs.
Yeah, so what did we actually end up testing here? So we opened the file, we read it in, and then we checked. Oh, okay. These were the 3 fields we parsed out. I remember now.
I think we actually parsed 4 fields, I thought. Let's see, if we look at the wave Dart file. Oh, no, you're right. We parsed chunk ID, int format. And I unfortunately did close the Chrome page that we had on the wave format, so I'll have to pull that up again in a minute.
I think you copy and pasted a bunch of it into the file as comments.
You're right. Right there. So this is copy pasted from the internet. So this is what we did. The first 4 bytes are this chunk ID. We had a whole long discussion last time about is this little Indian or big Indian. Turns out Wave is little Indian, except it has a big Indian variant. The file that we're dealing with is little Indian. So I think to close the loop on this, if I run this now again, having fixed the pub problem, this should just run and prove that our testing setup works. Normally, I would expect it to be significantly faster than this.
Oh, you're installing the JDK. When in doubt, install a JDK.
Maybe that run button was not the thing I wanted. Maybe it thinks this is like a Flutter test or something, and so it's like trying to build for Android. It
says Java on the side, so I wonder if you have Android selected as your target.
Java? Yeah, what is it even doing? Task. Any idea how Stop. Okay. IDEs are too complicated for me. I'm just going to go to a terminal. Oh my God, we're Gradling.
You could end up with an Android application that can run WAV files,
Stand back while I fetch the internet. Okay.
Maybe while that's going on in the background, we should spam out the rest of the fields in the WAV file.
We might get the whole WAV file done by the time Gradle downloads.
Yeah, it's possible. You never know.
Well, if we just go to a command line, like our normal real command line, and we run our test, this should take all of a second. It's going to make a fool of me again. Maybe because it's using 18 cores to download. I don't know.
I don't know why I find this entertaining, but I do. All right, all tests passed. That's really good.
There we go. It only took several seconds. Okay, and we finished downloading Gradle. No, we have not.
That's okay. I should just let it go. It's going to download Gradle.
I can't stop it. I don't even know. Oh, okay. I wish I actually knew how to use an IDE.
It's a very powerful tool, as you see.
Anyways, back to the task at hand. I'm really tempted to just quit the app, but then I don't know how to. Okay, I'm doing it. I'm doing it live here, folks. I'm going to quit Visual Studio Code, dropping Adam off the call.
Oh man!
And now I'm going to reopen it. This time, hopefully, with fewer Gradle downloads.
That will find out how smart it is. It's going to remember that it was in the middle of downloading Gradle.
Okay. And now, do I need to reinvite you, Adam? Have you?
Probably. Oh, wait. Recent contacts. Join. Did you start a collaboration session? You have to reinvite me. I don't know if you want to go off stream to do that.
No. It correctly does it No. It correctly does it where you can't see it. So it may have been designed for this. Start a collaboration session.
We were so good. We did this in the green room. just like professional podcasters.
We were so prepared. I want to sign in. I apologize, Internet. We could have been more prepared.
We were prepared. we launched the Gradle missile.
Okay, I am going to hide the screen.
Just in case.
Just in case it.
The way when you're signing in with GitHub, it's. Oh, okay. You're online. I wonder if I could just.
I'm now online, so you may be able to see me. Yeah, it totally was trying to do Android.
I can totally chat you in here. Oh. I chat you inside Visual Studio Code.
What?
I was reading the docs for the live share extension. The live share extension is amazing. It has chat functionality. It has a code review functionality. It can do everything.
Oh, I found your chat. Okay, Internet. Welcome back. Welcome back to the party.
I'm joining the collaboration session.
And now you can see we're even chatting with inside. Okay, back to the task at hand. Now with 100% less Gradle and more awesome. Let's go back to our wave test. My guess is it thinks this is a Flutter file.
I think we shouldn't. Let's not worry about the test. Let's go to the actual wave file and start coding.
I agree. Let's do that. Lib wave file. Okay, so we had our little format, and then we get into subchunks.
I see. There are two chunks: format (FMT) and data. Okay, so presumably the data is actually in the data chunk, and the more metadata is in this FMT chunk.
Okay, so let's figure out what the first. Well, maybe we should figure out the wrapper. So let's just figure out what the first chunks thing is. So let's add a list, or this is not what we actually want. How fancy are we going to get here? Are we doing this like a streaming parse?
I think we should do it fairly simply. I think we just read it all in, and we can always refactor it later if we need to make it fancier.
We can also just, for simplicity here, my selection's all weird. I wonder if that's the live coding thing. Yeah, it's like as though I can't actually select. Okay, I figured out how to select it. Okay, so like I could do print first chunk header. This is kind of lame. Just to like see it fly. If we go back to our code, then we do lib wave. Oh, let's check. Undefined name bytes. Well, that's because it's wave here. Oh. I tell you, selection is weird. And I blame the live code extension. We may have to turn it off.
Maybe want to do this from inside the class. It might be easier than trying to do it from here. Because you pass the file off to the wave file class.
Yeah. I was just trying to like see it go. Oh, I see. Because we still have a copy of it, right?
I guess that's true. But I think it's called open file.
I see. It's called open file here. See, selection's all weird. I double-clicked, and then it like selected the whole line. Okay, so the first chunk happens to be a format chunk.
That makes sense. That's what the doc said.
So
I assume it's going to be laid out just like it says in that comment. I would even maybe just copy all those names into like member variables of the class.
Well, but I think we're going to end up with lots of these, right?
No, I think just one. There's one format chunk that says, here's the format for the data, and then after that, you get the data chunk. Yeah, wave is a very, very simple format.
Oh, I see. So there are just two subchunks. I worried we were going to have like an envelope, and we were going to have a list of these subchunks. Okay, that's fine. So
I mean, it's possible there's a fancy wave file out there that will find that way, but I believe this one is just going to be the simple.
Okay. This may not work. Like the whole.
You can shut down the live coding. It's not actually connected to me, so.
Oh, okay. Well, I'm gonna stop then because it just keeps.
It messes with your selection.
Yeah, something about that.
That's too bad. It was a neat idea.
And we can maybe make it work offline or something, but it's really hard.
Yeah, there's always like subtle effects in editing. I know that Eric has worked on a actual editing code before.
Yeah, I did. I spent too many years of my life working on text editing abilities inside WebKit. It was never like my primary gig, but I did contribute here and there to that code base. Okay, so we have a string. It's from the format. Subchunk ID, subchunk 1. I don't know what that that means. Oh, I see. So we actually don't need this. This is like...
Why don't we put it in here anyway? We can always remove things that we don't need. This will help us like keep in sync as we read through the file.
Yep, makes sense. Okay, and then this is a size, so this is an int sub chunk 1 size. And this is a tiny int here. Oh, I said this is an enum. PCM.
Yeah, so I'm sure we'll have PCM. PCM is like a very, that's like the sample-based. Last time we discussed that generally sound files are encoded as just samples on the waveform. So the PCM is just the, I wish I knew what PCM stood for. Let me go research that real quickly.
Okay,
Pulse code modulation. Oh, and there's this weird Adobe thing. Like sometimes to get better like representation in the base, they like, it's like logarithmic or something. Well,
I have some vague recollection of this, like when the size of sound files mattered. I mean, I guess they still do, but...
Oh, I think it was actually really for like audio cassette tapes, because the analog encoding on the audio cassette tapes was like the noise characteristics were different in the different frequency bands. And so they like smushed the frequency bands all around to get some kind of like better something. that's about...
You know, in the future, in the far future, some audiophile is going to be like listening to this old podcast from us and just cringing.
Yes. Well, I'm sure that the current audiophiles are listening to us like, these people think they know something about audio.
Yeah.
This is like I find this happens a lot in software engineering, where you learn like tiny bits of all these other fields, because really like software engineering like touches all these other fields that are the actual domain that you're working in. And so you end up learning these like obscure facts that you kind of get like half wrong.
I have a lot of obscure facts that are half wrong. Sample. And then if PCM, this doesn't exist. What? I'm sorry, you have a variable length?
I'm almost certain that it's going to be PCM, so I wouldn't worry about the stuff that doesn't exist in non-PCM. If it's not PCM, I don't know what we're going to do with it. So.
Then we're really in the Wild West. And what's this extra params? Oh, I see. That's...
Yeah, I think if it's not PCM, then there's extra bits that could be used for something that aren't used right now.
I see, because it's some... Then we have a variable length. Okay. All right, let's read these suckers in.
All right.
So I should have maybe kept the comments in place. That would have been smarter. But subchunk ID is...
So I like to use the split screen feature. I don't know if you have enough screen real estate for that.
Oh, I might. I have to close this thing, though. Oh, yeah.
Yeah.
Okay, and then I do this.
Yep. Then you can look at 2 parts of the file at once.
Oh, man. We're living in the future.
Yeah. This is why I like to code on like a 4K monitor, because I like to open lots and lots of these things.
All right, so subchunk 1 ID, oh, it's okay. So that thing, and then we have
the size.
Chunk 1 size. And this is, we decided we have this fancy way to get as int.
Mm-hmm.
I wonder if Indian little probably is the default, but we need to be explicit about this kind of thing.
Big Indian is the default, if I'm remembering Dart correctly.
Maybe.
I one time had a bug. That's usually how I do things. Is one time I had a bug and I had to like dig through all the code and figure out that there was like a parameter that was implied that was messing me up.
Centric size. Oh, this is 4 actually. This is the kind of stuff where like, oh man, I need to turn these into subfunctions.
Mm.
Whew. I'm gonna take a breath and keep copy pasting, and then we'll come back and turn them into subfunctions. Because like this is too hard for my little old brain to read.
Yeah, I like the like refactoring approach to programming, where you like write the ugly code and be like, that code's ugly. I must apply the beautification brush to it.
Audio format. Okay, and this is only 2.
You want to get int 13 out of it. if it's only 2 bytes. 16, sorry.
Why do I care?
Oh, because your buffer is only made 2 bytes long. If you try to get a 32-bit integer out of a 2-byte buffer, it's going to try to read 4 bytes and get mad.
See, this... Okay, int read short and
yeah
bytes int read long.
Go ahead. I nitpick you slightly.
You what?
Do you mind if I nitpick you slightly?
Please.
So short and long, you're sort of those are not really Dart concepts. Those are concepts either from C or Java or some other language. And so I think really to be idiomatic Dart, you would use like they have like int32 and int16.
All right, so read int16, read int32. Also, short and long like don't always mean the same thing depending on the compiler. At least I feel like I remember pain from Microsoft Visual Studio.
Oh, for sure. And I think that's why Dart doesn't use those terminology, is because they mean different things on different architectures.
What should we call this? Read string. I mean, I can just.
I would. I think it's called a chunk ID. It's like a riff concept.
Chunk ID? Really?
Yeah, a chunk ID is specifically these little 4-byte strings that they use to tag the different pieces of the file.
I really don't. Well, should I pass the bytes or not? Like, it's more testable if it isn't, but like, it's really, it's like I'm even calling this from the constructor. Feels like I shouldn't pass the bytes.
I mean, what I would do, if you're really asking, is I would create another class that was a riff class.
Oh.
Yeah.
Now you're talking.
Mm-hmm.
So this is like a riff parser? Or like... Yeah. I like it.
Riff has 2 bytes. Because it's everything in riff is 4 bytes. It's like it loves 4 bytes.
Okay, and so now we have a final
yeah, the random access file is totally final.
No, I'm always asking Adam.
And I would put an underscore to make it private. This is a Dartism. If you name your variables with underscores, and they're private.
I mean, the whole class is private. I don't actually think you want. Like, I think. Okay.
You don't think so? Okay.
I think you want that to be. We'll see. We'll see how it feels like.
So the reason I would go for that is because random access file is a stateful object. It has the seek pointer inside of it. So if somebody outside of your class is poking at it, they could really mess you up.
Yeah. Okay, you're right. Good. And then we don't need this. We don't need this. Don't need this. And these obviously are not abstract. About to teach the world how to reuse them. I will say there are a bunch of little Dartisms that I've gotten used to and really like. I know lots of other languages have these things, but like, I like Dart's little one-liner functions. I like the syntax.
I think they have this in JavaScript now. I think it works really well in JavaScript as well. Yeah, JavaScript has this funny thing with the this keyword, where it somehow isn't really tightly associated with the object, but they fixed it with these one-liner double arrow functions.
Oh yeah,
this is really cute. I haven't written JavaScript in like the modern world when they have all these fancy features.
Oh, not at all.
But I've read about them and be like, yeah, I can totally see that.
Yeah, I have not. I actually worked on a JavaScript engine. Worked on JavaScript core on a couple versions of it. Very long back in the day. And as you were saying earlier, it's one of those sort of CSE things where like, I got enough knowledge to be dangerous. Like if you say this to like a modern, like if you say this to a V8 engineer, you're like, haha, you don't know anything about JavaScript engines. But like I knew a little bit for a brief period of time. It was glorious.
I think this is why engineers get in trouble when they start talking about like other fields, like when they start commenting on like public policy or like, health policy or stuff.
Yeah.
Because in engineering, you can sort of get away with this like very partial knowledge because you'll run something, your test will fail, and then you'll have to learn something more. But you can't really like run tests in other fields. Like it's not quite quite how they work.
Yeah. I was, we have some construction going on. I was watching some cabinet installers do some cabinet stuff, and I was just marveling at how, good they were at their job. But also they were dealing in the physical world, and they cut a board to the wrong size, so they had to go like throw it out, and like
There's no undo button.
there's no undo button, and they were like futzing and. Anyways, okay, so riff parser bytes, and this is parser, and then now we can make this all awesome. Read chunk ID.
Oh, the beauty is overwhelming.
I just couldn't take it anymore. Is there a way? Okay, that's better. Something feels off in like the selection. I don't know whether that's like my poor little machine is overloaded. I don't know, whatever. Read int. Oh no, my machine just feels janky. This is a 32, I think.
I mean, if you want to get super fancy, you can make read chunk size. That just delegates directly to read in 32.
What do you mean?
Well, the chunk size is also a riff concept. Every chunk in riff starts out with an ID and then a size.
I agree with you. What I'm going to do, though, is do that in another pass. Yep. If we get there. My eyes have stopped bleeding now.
This is like really hard aesthetic to capture, like because you could spend forever like polishing off every little grain of sand and every bump, but like it's not really where the return on investment is. Like the return on investment on this refactoring you just did is huge because now you can read this. It all fits on one line. It's beautiful.
Well, I couldn't tell what the code was doing before. Like it was just a pile of copy paste, and I just didn't know if I had gotten it right. That was why I had to do it. Yes, I hear you. Sorry, I was trying to be emphatically agreeing.
Yeah, absolutely.
Okay, so now, oh my God, we can do so many of these now. What is this? Num channels?
Oh, okay. This is interesting. We're going to have to figure this out later, like, because I bet we have two channels in this file, like left and right. Anyway, I guess when we get to the data block, we'll have to see how that works.
Sample. It is a little unfortunate that we're like so off where we set out to do, but this is all the fun.
I find it interesting. Like I feel like I'm learning a lot about how Wave works, and like you're not always going to have a library off the shelf that you can go pull down. Like reading a spec and like coding to the spec is totally my jam.
Amen. You and I have built a lot of parsers together. Maybe that's how we just end up building parsers.
Well, there's something that's like there's only like three kinds of I don't know how many it is, but there's only like a few kinds of programs. There's like the parser. There's like the I don't know what they all are. I'm sure somebody's written a beautiful essay on the internet that like gives you a taxonomy of all like the database. Like
I believe you that taxonomy exists. But what am I doing here? Okay, block a line, and then bits per sample. Right?
Mm-hmm.
And this one is, yeah, you were saying, sorry.
I think we're going to get to something a little tricky here.
What about?
So we've read out all these fields, and then above we were told how big this chunk was. And I bet that it's possible that there's space at the end of the chunk. Like I think that's what that X is like hinting us at.
That's fine. We can just skip. Right?
Right.
So there's like, and this gets to the, yeah, so it's like you just want, I feel like I've written this exact parser file split before.
Well, I mean, do you want the fancy one? So the fancy one that I would do is I'd have the riff parser give you the next chunk. So it would vend you like a chunk at a time. So in riff, the chunks are in a tree, right?
Okay, I don't have enough. I know you spend all this time with riff That's not in my consciousness, right?
Yeah. So the way a file works is it's just a tree of chunks. So everything. So like the root chunk is that riff file that just said riff and told you how big the whole file was, and then we did the wave chunk and then the format chunk. So like if you were a fancy riff parser, you would give you that by like letting you walk through the chunks of the riff file. Anyway, we don't have to do it that way. That's like the fancy way.
Yeah, I think we'll get to more fancy here, or we may, depending. I mean, maybe we'll spend a whole bunch of time writing a wave parser.
Because this little bits of math you're about to do here is sort of a little fiddly, right? So
I kind of want to get back. I want to close our cycle time here. Like I really want to print something back.
Okay.
I also feel like I'm missing a bunch of asserts, but maybe I should do some printing first. Like,
why don't we just print it out and see what our file has? I'd just be interested to see what values each of these fields have in our example file.
Where should I do that though? Should I print them right after I read them? Oh, that would be easier. What do you think? It's really not the right style. It's like I have to copy paste all this code in order to print it all again.
Mm-hmm.
It feels lame.
Well, what about a debugger? Could we look at it in a debugger?
Sure. So we just...
Maybe this will get us back to our Gradle.
Yeah, we're going to end up trying to install Gradle here. But I think there's a way to tell this sucker that this is a... Like what I want to run is Dart.
Hmm. Well, there's a little Flutter icon there on your left. I don't know what that does. Do you see on the left bar you've got a Flutter icon?
Yes, I think that's the Flutter... Oh, interesting.
That's cool.
This is it's like the test configuration. This sucker, maybe. This isn't quite it, though. I wonder how much stumbling we want to do here on camera.
Okay, we can also just copy and paste and write all the print statements. That would also totally going to work.
Yep. Okay. So these are all the ones we need to still do. So we're going to move these down here. We can do this.
Are you like a vertical editing guy?
What do you mean?
Vertical selection?
Oh, I never remember how to do it, but yes, it's like control. Lots of everything funny mapped on this keyboard. So, do you know what the? There we go. But
go down to where you have all the labels.
Yeah.
And so that first line, you should align it so that it's vertical with the other ones. Yeah. Now do a vertical selection right before, of 0 width and height. Then start typing like print. I love this. This is my favorite trick in the world. And then you can do control right arrow to select a single word on each of them. Oops, I meant control shift right arrow to select a word. Yeah. Oh, your word things are too smart. Anyway. You
should be able to select to the next white space though.
Yeah.
It's really close though.
It's really close. Anyway, when I get set up in an editor, I totally like. I mean, this is why I was addicted to VI for so long. It's because I like learned the vertical selection thing, and you can just like really do this kind of work really fast.
I mean, there's so much more we could do here. Okay. All right. I'm going all in. So I believe we can do what you want to do. You said there's control? No, it's this one.
Oh, from the end.
From the end. Well, somehow I didn't catch them all. Well, you can also get to the end this way.
Uh-huh.
We're so in the weeds.
I don't know. For a pro tip, vertical selection.
Okay, now
You got to fix up the first one. The first one got messed up somehow because it was a string instead of a thing. Yeah, yeah. Now you totally got it.
but we still need. Well, oh my God, what are we doing?
This is quality television, ladies and gentlemen.
Not only is it quality television, it's quality engineering. Oh my goodness, I don't know what I did, but I somehow got it. Okay, and I copied it all, which was the important part.
So yeah, I've always wanted to write a text editor that could do this. I at some point I wrote my own text editor, and
oh my God, this is working.
It could like edit one line of text, but this clipboard thing where like each of the vertical cursors somehow has its own clipboard. I'm just like trying to imagine what the data model is. The data model must be, it must be that the clipboard contains a single string with multiple lines, and then each cursor pulls like one line out of the clipboard or something. Anyway, whenever I see like a bug in a piece of software, I'm always thinking to myself, like, what is the like? How did the software have that bug? Because like human beings are smart; they mostly write code that makes sense, and so the code that had the bug must make sense as written on the page.
Sure.
So then I try to imagine like, what must the internal of the software be like, such that this behavior that makes no sense to the human being using it makes sense on the page in code.
Okay, we could have copy pasted it 18 times.
Okay, so if you're, I don't really like. There's this XKCD comic which you must read if you're into this kind of stuff. But there's one. We should just like get all the numbers for these things and put them in the show notes. But like, there's one about how he like is doing a task and then he builds a machine to do the task, and he spends so much longer building the machine to automate the task. Oh, we have all the stuff.
We have all the stuff. It worked. And okay. I learned how to better do selection.
Oh, look at this. It's got 2 audio channels. It's got a sample rate of 8,000. 8,000 what? I don't know. We're going to have to find out. It's got a byte rate of 32,000. Block on 16 bits per sample. I mean, those numbers make a lot of sense. Mm-hmm. It doesn't look like garbage at all. It looks like you totally got it.
Audio format 1. That's the PCM.
Yeah, I remember that from the comments. It said that 1 was PCM.
Okay, so what's next?
Let's try to get the data, right?
This is the format chunk?
Yeah. Okay.
So we have to figure out how long is the chunk size.
Well, it said the chunk size was 16. So, like part of the trickiness here is I'm not sure how many bytes you've actually read in each of these things.
I mean, we could have like a chunk counter or something. I mean, we have to make our parser a little smarter.
Right. So maybe it should keep state of like,
I mean, it's like you could do something like this, where you do int chunk since chunk start, something like that.
Well, that's
the right name.
You might want to like tear off a chunk object. So you like go like read me a chunk out of this riff file, and it gives you like another object that's like, here's your chunk ID, here's your length, and then maybe the chunk will remember its start offset. So then you can ask the riff parser for the next chunk or something. Because there's this funny thing where like some of the state for this class is hidden inside the random access file.
But the random access file is just part of the riff parser. So even if it's hidden inside, like as you made it a private of the riff parser, right? So the riff parser is the thing that has all the state, and you don't know the random access file is just an implementation detail of it. Like we could call this var, like we could make this var to like that clearer. It's like we just pass it off to the riff parser, and we don't know what the heck this is.
Yeah. Yeah, so I think somehow if you give the riff parser some concept of a chunk where you can like start a chunk and then like go to the next chunk, then it could do the bookkeeping of like where the offset is in the file for the next chunk.
I like that name. So like next chunk is, it's not perfect, but we can start with that, right? And next chunk for now, all it does is it just resets the since.
Well, I think random access file has a seek operation. So instead of like doing bookkeeping on every single read, if you just remember where you were when you started the chunk and how big the chunk was, then when you go to next chunk, you can just call seek and seek right there.
When you call next chunk, you're imagining passing at something? Oh, you're just saying just call a seek from what I knew my start to be. You're offering a different implementation of skip.
Right, so I wasn't going to do skip, right? So skip implies start with my current seek offset and then work delta from there. But the random access file will have a seek that's an absolute seek. So you could do an absolute seek to the next chunk.
Oh, or I can do a chunk relative seek.
Oh yeah. So the key is to remember where the chunk started, right? And then since you have the chunk size, you can do like a chunk relative seek. Yeah.
So start chunk maybe, or next chunk? I don't know what we call that. But then we do chunk relative seek. That's a terrible name, but we'll pretend. And we do sub chunk size, and then we're doing parser.next chunk.
Well, I think if you look at what you've written, you're sort of dancing around. There's this chunk concept that hasn't been reified, and that's why I was trying to get to the point of reifying it in some way.
I'm just not sure what it. Yeah, I don't know if we know enough to reify the chunk concept yet. Right, like
so. I was just imagining it as a class that had the ID and the size.
Okay.
And then.
Yeah, speak to me. Class. Riff chunk.
Riff chunk.
And when you say ID, what do you mean?
So you see how in your wave file, remember you commented earlier that the like format string didn't really belong in the wave file? They really belong in this riff chunk object, right? Because they're not really about the wave file, they're about the encoding.
Yeah, okay, now we're making sense. So, okay. Yeah, I like it. So it's this, as you said, it's like a tree.
Yeah, so the format thing doesn't go here. They
Why not?
Just,
It's common to all chunks, right?
So the thing that's common to all chunks is the first string and the int, the size. So it has an ID and a size.
Oh, it does. The format is not. Oh, okay, that's fine.
Yeah.
But it also needs. We need to like know its location.
Right, like where it is in the file. So it's like it has like an offset.
And this is some like kind of hidden thing. I don't know.
No, it can be public. I think all these things can be public and final. And when they're just like instead of reading an integer out of your riff parser, you'll read a chunk thing.
Oh.
And then you can ask it to like give me.
I love it. You tear it off.
Yeah.
Yeah. Okay. And so then it has a final random access file.
It doesn't even need to have that, right? When you read an integer or a string out of the riff parser, it doesn't know anything about the file it came from. It's just like, here's the data you read.
Well, it needs a buffer or something like that, right? Because when you tear off a riff chunk, the riff chunk itself doesn't know anything more than, as you said, its ID and its size. Right?
Oh,
so
I see what you're saying.
You need like a buffer to read from.
Yeah, you're totally right. Yeah, absolutely.
So what is this final? We had a
file, right? Just random access file.
But as you said, then we're gonna have to seek it every time, aren't we?
Well, maybe you like start when you want to engage with a chunk. You like say, okay, I'm going to start reading you, and it does a seek. I think it should be the caller's responsibility to manage that somehow.
I mean, you also, when you create the chunk, you could just read the entire chunk into, like, you could just read the chunk size and then you just have a byte buffer.
Oh, yeah. Okay.
What is that called?
It's called the buffer.
Well, what's the
it's my favorite trick for naming things. You just tell somebody to tell you about it, and they'll give it a name, which is like the subconscious obvious name.
It's the byte data. It's byte. It's a byte data. Okay.
So it's the thing that I keep repeating.
Final byte data. And then we actually don't need the chunk size anymore, but whatever.
That's a good point.
Like that's now implicit in the buffer. Oh, what did I do? Right.
Mm-hmm.
And the ID is honestly the first 4 anyways, but we can have it cached out. That's fine. Okay, so now we want to like...
I think you want to make a constructor to let you construct that pretty easily.
Yeah, I agree. But it's going to be a simple... This is like a data class, basically. Riff chunk this dot... Maybe it's just offset? I feel like we're...
Yeah, you don't have to repeat the word chunk.
This is ID.
Mm-hmm.
Offset this.id, this.buffer.
I would totally use named constructors since this is Dart. You're never going to remember like what order these things go in.
Ta-da.
Yeah, this is legit.
Okay. The other thing is that when you write parsers 30 years later, you always write them slightly differently. And so then your mental model doesn't exactly match.
Yeah.
You realize that we're going to have spent the entire hour debating the architecture of our parser for
yeah, well, okay, so that's fine.
Anyways, I had a good time. Okay, we have 13 minutes. How do we get to a test? Or some running code? Okay. Okay, so we don't need this anymore. We basically need like just a read chunk, right?
Mm-hmm.
And so who has these? We're going to have to read offsets from the byte data.
Yeah, but it gets to be nothing, right? Because most of that goes away, right? All you're going to do is say chunk.buffer.get in 16. You have to say little endian a lot.
No, well, the problem is that this the random access file with this read sync had our enumerator or iterator in it, right? Now, if we pull out all of the buffer, I was imagining this is the full, you pull out the entire length of the chunk into a buffer. You've now made a copy.
Mm-hmm.
And so now you have to build a new iterator, right, that remembers.
Right, so, okay, so that's true. So maybe you don't want to do that. Maybe you just want to remember the size. And then you can have a function on the riff parser that's like, okay, here was the chunk I was working on. Now give me the next chunk. And then that'll do all the seeking for you.
Okay, so you're saying we don't keep the buffer. I mean, we potentially could keep the buffer. Oh, no, actually you can't because you do it in the reading, but that's fine. All right, so this dot size is final int size.
Yep.
And
so then instead of skip bytes, just say like next chunk, and you pass it a chunk and it gives you back a chunk.
I see. Instead of skip chunk, you say it just takes whatever the current chunk is, reads to the end of it. So this does the skip logic for us?
Yeah, so I was imagining if you pass in a chunk as an argument here, and then on your bytes, you're going to call seek, and you're going to seek to basically offset plus size.
I see. So you want bytes.seek to chunk dot offset plus chunk dot size.
Yeah, you're probably going to have to like tell seek that you want an absolute seek. Oh, set position sync is what it's called.
Sold.
Sorry, my brain works in POSIX.
No, that's fine. Mine does too. That's been my entire career. Okay. Next chunk.
And then it should return you a chunk, right? Because it the very first thing you're going to get is a chunk.
Well, but now we're going to have to, when we don't have our current, like, how do we get our first chunk?
Oh, well, you call read string. You say you read a string. So you should remember that offset, right? That you just computed, because that's the thing you want to shove into the chunk that you're returning. And then you read the 4-byte string and you read the 4-byte size and then return it.
I see. So what you're saying is that this is int start of next chunk offset is that. And then we want to return riff chunk. And you said this was offset next chunk offset. And what else were we supposed to do? We're supposed to like also do a read. Like where is the iterator set at the beginning of after next chunk?
After next, we could document it. We should write the documentation. But I imagine the iterator is set right after the metadata for the chunk. So it's set right after the size of the chunk. Because the client is never going to want to read, like, you're going to read the two blocks that are the two things that are always there, and then the client's going to want to start reading after that. It's a little wonky.
Yeah, I think we should sort of wind down in our last 8 minutes so we can get to like some stopping place, but we go a little long. Size. So, and now it matters what order I read them in.
Mm-hmm. Yeah, so I think you want
it's ID and size.
ID first, then size.
So I want to read these separately. String ID is equal to read chunk ID, I think we called it.
Yep.
And then string size, read int 32. And then this is a little wonky, but maybe we'll fix it.
Yeah, you often have to like explore a little bit to like try things out and like.
Exactly. Well, that's some of the fun too. Okay, why do we have a zillion? Well, that would be one. We have all the errors. All the errors. Why not have all the errors? This sounds like a factory method.
Yeah.
So
I think we can work with this. I think the platonic
like next
is a little different.
You know, chunk after, it's like
it's really like next. Yeah, or like there's like an implicit iterator in here, right? You're iterating through the chunks, which also isn't reified. But conceptually, you should have an iterator that you then get the next chunk from, and it holds on to the previous chunk or whatever.
Yeah, that's next time.
Yeah, we're
okay, so but how do we even get our first chunk? So this is.
Oh, we need a first chunk method, obviously. And the first chunk is always going to be this funny riff chunk. Because that riff is awesome.
Well, it's not funny, though. Like, it's... but this chunk size, actually, of the riff chunk is the whole file size, isn't it?
Mm-hmm. Yeah, because it's really a tree.
I see. So, like, we don't want a next chunk, the first chunk.
Well, I think... Well, I think if you have a chunk, you could either get the first chunk inside of it, or you can get the next chunk. And those are two different operations. And that'll let you walk the tree.
I see. It's like okay. It's like first child versus next sibling.
So maybe this is like sibling chunk. Get sibling. Get next sibling. Yeah.
Sibling. Okay. Let's pretend
And
that.
And then there's get first child. We could turn anything into a web browser. Just give us enough time. It'll look like a web browser. Believe me.
And first child, like, and now we're passing in this, right? So like, are these really methods on riff chunk? Well, whatever. We'll deal with that later. This is still not designed right.
It's not quite right. It'll eventually be exactly like a web browser. Do not worry. We'll get there through successive refactorings.
Oh, now you're reminding me of like the start of Flutter and how we ripped the engine out of whatever. That's a story for another day.
What it really reminds me is I worked on a project that had a file system.
Yeah.
And the first team of people that we had to try to build a file system, they were database people. They knew all about databases.
Sure.
And they built the file system as if it were a database. And it didn't work. It turns out databases and file systems,
they're not the same thing?
But they're not the same thing. And so then we then had a team come by and they built it. They were a file system team. They came from the file system culture and they built it like a file system and then it worked. It's kind of remarkable. But I think it's because of this thing, because like, you and I have this shared context and I worked on web browsers for a long time.
Yeah.
So we know how all that stuff fits together and it fits together in some way.
And so we just build web browsers.
We just would build it doesn't matter if you're making an audio visualizer inside of it, it will have a web browser.
Okay, so how do we get to a stopping place? We're so deep in the yak shaves here.
Well, I like in the same way we could just extend the test that we have now to basically test all those other fields that we just printed out.
Well, but we don't even have a compilable thing at the moment. We've torn ourselves. Oh. Like we're deep in this like riff chunk.
It's a minor detail.
We're in this like riff chunk, half baked. First child.
Why don't we finish the first child next sibling thing, refactor it to use that, and then write the test that will test the fields that we've already read out. Well, and then we'll start next time reading the first.
I'm going to just comment this out. Like it's not clear that this was the right.
Okay, that's fine too.
Well, I like your riff chunk abstraction. I'm just not sure that this seeking.
Yeah, the seeking thing isn't quite right. I totally
like. Well, I think it's also because we wedded the seeking thing with the chunk creation. It's like seek to after.
Right.
Would just be simpler, right? And now we can. Now we could separate that into a.
Oh yeah.
Riff chunk, start chunk.
Or just read chunk, right? And read chunk would just read you the chunk object, and not mess around with your.
Or read chunk.
Yeah.
Header or whatever.
Yeah, read chunk header. Right, and so the first thing you're going to want to hear is capture the offset, which you can just get by. I presume that there's a position sync. There's a method on random access file called position sync. You have to call it before you read stuff and mutate the. Yeah. No, you're totally
right. I mean, this is.
Now that's not a web browser anymore, Eric. Clearly, we've been messing up. Now it's a parser again.
Yeah, it is. It's like a Sax parser or whatever. It like has state. I mean, we don't have callbacks, right, for Sax, but okay. What did we do here? Bytes offset is not the thing. So this actually makes it though. You don't need first child because now we can call this right away.
Yeah.
Right. So this is a little. Still maybe a little weird, but riff chunk, what do we call this, root chunk?
Yep.
And this is.
And then you can take these fields away from the wave class if you want, right? They don't really have anything to do with wave. So here you could assert, right? or like
Let's just leave them for now, just in the interest of getting to like a testing state.
Yeah. Yeah, like there's another sort of structural problem here, which is because we're doing the parsing inside the constructor, there isn't a clean way for it to error out.
Oh, totally. Yeah, we totally shouldn't be doing the parsing inside the
yeah.
But we can solve that next time.
For sure.
And this is also weird that like I see this is. Yeah, we sort of like started down this riff chunk thing. We just haven't quite.
Yeah,
so this doesn't.
I quit living the dream. Right, so now we need to get the format chunk.
Well, but.
Yeah, this is good.
For consistency, we probably actually want parser dot. Oh, we don't actually, because now we're still inside that chunk. Okay. Yep. So this is format.
Something's a little funny. Let me research it while you refactor here. Oh, okay. Got it.
Okay. And so we now can do like skip to end of chunk or something. Seek
to
after.
Technically, we should do that before reading the format chunk.
Oh, because that's because we're still inside the root chunk.
Oh.
I also had that same thought.
Oh, you're totally right.
And in fact, this is where we leave comments, right?
Yeah, you should totally comment that because that.
We don't.
Yeah, this is like
riff is a nested tree structure. We don't seek to the end of the chunk here since all other the remaining chunks are still inside this root. If I actually sent this up for code review, someone would help me rewrite this as like one sentence instead of 4 lines. But okay, so I think we should.
Do you want to run it from the command line again?
Well, we got to get past our problems here. Local format can be referenced before it's declared.
Oh, I think you named 2 things format. I think you want to call it like root chunk and format chunk because you have a member variable called format. That one's fine. Yep. It's the next one that wants to be format chunk.
And that's part of our like incomplete string. Yay, types. Okay. See if it still works.
Yeah, this is okay. That looks sane.
Interpreting this package as URI.
It complained about that last time too. I don't.
Oh, I think because it's expecting this to be passed to URI. This is just Dart, the command line. Oh, because it's this fancy new. We're no longer calling the Dart executable directly. We're now calling a Dart wrapper. There's a Dart wrapper now, like the Flutter wrapper. This is brand new in the last couple of weeks.
Oh, I see. Okay.
So it has slightly different file handling now. So it's like, hey, you passed me a path.
I see. So you want to say Dart run lib wave or whatever?
I suspect that is probably exactly what you want. It probably still. Wyatt thinks that's a.
It's okay. Let's not worry about it. This is.
Yeah. Whatever. Okay, we're well into the weeds again. Okay, so yeah, let's test this sucker. So our same problem that we have this kind of funky testing setup.
Yeah, we discussed this last episode. I can recap while you're typing it.
Yeah, please.
So this test has a funny fixture because it depends on this random file existing. And so what Eric was saying last week was that it really should be a more self-contained test. So like in sort of the ultimate version of this file, you have both like wave encoder and a wave like parser. And so you would like feed one into the other to make sure that it's like round trips correctly. But for now, I think this is sensible. Keep ourselves code that works and compiles.
Yeah, you had this analogy, I don't even know if it was on stream or off stream last week, where you talked about how one of the things you like about CS is that you feel like you're always just like placing one grain of sand on the pile. Like with each, I'm not quite capturing your words correctly, but.
Yeah, there's this beautiful art. If you've never seen it, you should take a look at it, where it's done by just placing one grain of sand at a time, and it builds this beautiful mosaic. And it's done in this way where you basically build this thing, and you have the experience of creating it. And then there's a very important step at the end where you purposely mess up the whole thing that you've created by like sweeping your hand over the sand. And like somehow that's part of, I've never done this. I never actually built one of these mosaics. But my understanding is that the creation and destruction is like part of the experience of making that art, which I always thought was a really cool idea.
I find art that like embraces the ephemerality to be both like interesting and also conflicting. Like I don't think a lot about like ephemerality of all the things that we do, but you know, some art like really leans into that. Like it's intentionally a chalk drawing that, you know, is gonna like get washed away. And that's both compelling and like somehow threatening.
I mean, the way I understand it is that it's about loving the process. So like, I really enjoy the process of writing software. Like all these discussions we're having, like the whole purpose of this podcast is to do this enjoyable activity. And so, but you can also get wrapped up, especially in commercial software development, in the thing that you're producing, because it often has significant economic value. And so part of, I think the idea of like, creating and destroying is to get yourself really engaged in the process. And that's where I find sort of the beauty and elegance of all of it to come from.
The quirk of large commercial software development is that you have to work with so many other people, which is both good and bad. But like it forces this compromise. Like it's not exactly the way that you wanted it, because you have to, in order for it to be like workable on by 100 people, you have to somehow compromise with 99 other people. I guess it's less so about a chalk drawing on the. Okay, test. Let's run our wave test. Hit pass.
Oh, test pass. Yay.
So, yeah. So we mostly did refactoring today.
I think so. I think we're in a position where next week we could read some data samples, and I think it'd be really cool before we do the like frequency transform to try to like just plot the data samples we get.
Oh.
Hopefully they'll make a wave. I don't know.
I mean, another thing we could explore is to sort of parallelize this a little bit. I mean, so much of this is just the fun of doing this with you. But I guess we got less far along in this than I had hoped. But some of that's also just getting started. So, anyways, I had a lot of fun as always. Wonderful to spend time with you, Adam.
Yes, this was a lot of fun.
Anything more you want to say to the internet before we sign off?
No, just see you next week.
See you next week. We'll find a regular time. This was we're still settling in, but we'll start seeing you all at a regular time.
Awesome. Thanks, Eric.
See you, Adam.